Hello guys, welcome back to my YouTube channel. Today I am going to solve day 18 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 979, distribute coins in a binary tree. Okay, so in this problem you are given the root of a binary tree with n nodes, okay, and where each node in the tree has node dot value number of coins. Okay, so there are n coins in total throughout the whole tree, and in one move we may choose two adjacent nodes and move one coin from one node to another. Okay, a move may be from parent to child or from child to parent, and in the end we have to just return the minimum number of moves required to make every node have exactly one coin. Okay, so now let's understand this problem with an example. Okay, so let me copy this example. Okay, so now see here, so this is the example one given to us, right? So in this problem this is my tree. Okay, so from this tree, if I move one coin to my left child, so then my tree is going to look like this. My root node will become 2, my left child will become 1, and my right child will become a 0 only. Okay, no change in this. Okay, then after that, if I move one coin from my root node to my right child, then in that case my tree is going to look like this, right? And this is what we need, right? So in total how many moves we are taking? This is first move and this is our second move. Okay, so the output of this example is nothing but 2. Okay, this is example 1, and let's pick example 2 here. Okay, so let me copy this example. Okay, so this is our example 2. Okay, so see here, first see in the left child we have total 3 coins. Okay, so first what I'm going to do, I'm going to move one coin from my left child to my root node. Okay, so my tree is going to look like this. Okay, this is my first move, right? This is my first move. Then after that I am again going to move one coin from my left child, okay, from my left child to my root node. Okay, then my tree is going to look like this, 1 2 and 0. Okay, this is my second move, and in the end I am going to move one coin from my root to my right child. Okay, and in the end this is how my tree is going to look like, right? So see here, in total we are taking 3 moves, 1 2 and 3. Okay, so our output is 3. Okay, so we have to form a tree, okay, in which all the nodes contains exactly one coin. Okay, this is the requirement. Okay, so now let's see how we are going to solve this problem. Okay, let's understand the approach. Okay, so let's understand the approach with example 1. Okay, what I'm going to do, okay, in the example 1. Okay, so this is my tree, right? 3 0 0, this is my tree. Okay, so first I am going to look for the left children, then after that I am going to look for the right children, and then after that I am going to check for the my root. Okay, so I'm going to say mid. Okay, so this is nothing but my left children, right children, and then mid, nothing but my root. Okay, so what is this traversal? This is nothing but this is post order traversal, right? Post order traversal. So first what I'm going to do here, this is my root. Okay, I'm going to go in the left child, okay, from this root. Okay, after reaching to the left children, again I'm going to go to the left. Okay, once this left and then again left, and here see the value of node, this node is null. Okay, this node is null. Okay, so from here I am just going to return 0. Okay, from here I am just going to return 0. Okay, then after that I have solved my left. Okay, so in left I don't, this 0 is nothing but this means that in the left I don't need any coin. I don't need any coin. This 0 means I don't need any coin in the left to balance it out. Okay, because this is null now. We don't need to do anything. Then after that I am going to go in the right of this one. Okay, so in the right of this one, value is null, right? Value is null. So okay, so from here also I am going to return 0. Okay, this 0 simply means that I don't need any coin for this node because this node is null. Okay, there is no value here. Okay, null. Okay, so now after that I have to find out how many excess coins that I have at this particular node. I have solved for left, right? Left is null. I have solved for right. Yes. Now I am going to check for the root, that is my mid. Okay, so how many excess coins I have at this root now? Okay, so number of excess coins. How I am going to count excess coins? So simple formula. What is the value of this node? The value of this node is 0, right? Plus how many left excess children he needs. Okay, so this is my root now. So how many children my left node needs? How many children my left node needs? No, nothing. No children. It requires no children, right? How many children my right node requires? Okay, right child of this root requires nothing. No children. 0. And then after that I have to subtract -1. Why -1? Because this root node also needs to maintain at least one children, at most one children. Okay, so that is why I am going to write 0. Okay, so simple way. Let's see here. If my node has 2 children, then how many children he can send to some other person? Okay, one children he can send it to other person. Okay, because there is one excess children. Okay, because we need at most one, right? So one excess children. So if this node value is 0, then I can simply say -1 excess children. There is one children less, right? So I can simply say -1. Okay, so that is why now see this formula is going to give me -1. That simply means that this node has one less children. Okay, and it needs at least one more children, right? So I hope that this line is clear. Okay, so here I am finding in green color pencil excess children. So here value of excess children is nothing but -1. Okay, this is done. And how many moves we have completed till now? 0 moves, right? This node doesn't need any children. This node doesn't need any children. This node needs -1 children. We didn't move anything. Okay, this is just a requirement. This node just needs -1 children. This is the requirement. Okay, we didn't move any children yet. Okay, so my number of moves is nothing but 0 here. Okay, so from here I am just going to return -1. -1, that simply means that this root is going to need -1 number of children. Okay, this value I have solved now left. Okay, this is my left now. This is my left. Now let's solve the right of this part. Same way, this is null and this is also null. Okay, so no children are required by both left and right of this node. Okay, and how many excess children this node requires? Same way like left child, this node also requires -1 child. Okay, -1. Excess value is -1. Okay, this is how I am calculating my excess value. The value of current node 0. Left excess, so this left child doesn't need any children, 0. Right child 0 and -1. Okay, because this node needs at least one children, at most one children. Okay, so here this is giving -1. Okay, so here from here I am going to return -1. Okay, so from both left and right child of this root I am returning -1. Okay, so I have solved for left, I have solved for right. Now I have to solve for mid. Okay, so for mid, now let's find out how many excess children in my mid. So for same formula, excess children in mid is equal to value of this node 3 minus 3 plus left excess children. So left excess, so from here the left node is asking for -1. Okay, left node is asking for 1 children. Okay, so here I am going to write -1. This right child is also asking for -1. Okay, one more children. Okay, so here I am writing -1. Then -1 we have to subtract because this root node also needs one children, right? One child, right? So what is the total value I am getting here now? 3 minus 1 2, 2 minus 1 1, and 1 minus 1 0. Okay, so there is no excess children. There is no excess children now left out. Okay, I hope that this is clear. Simple way that if a node has one children, then excess will come 0 only. Excess will come 0 only. Now, if any root node value is 1, then excess will come 0 because there is no extra children. Okay, why there is no extra children? For this 3, because this 3 is going to give 1 children to this left. That is why we are writing minus 1. And this 3 is going to give 1 child to the right. That is why I am writing minus 1 here. And minus 1 we are subtracting because this node also needs 1 children. So excess children is 0 right now. Okay, the excess children is 0. Okay, this is done. And now I have to calculate the moves, how many moves that we have applied. Okay, so now how I am going to calculate moves? Moves is equal to moves plus absolute value of left excess. So absolute value of left excess is, this is minus 1, so I'm going to write absolute value 1. Okay, initially my moves is 0. Right now my moves is 0. 0 plus 1 plus absolute value of right excess minus 1. Absolute value is this one, 1. So total moves that I'm going to get is 2, and this 2 is my output. Okay, so I hope that this is clear how I'm going to solve this problem. Okay, this is done. Now let's understand this same thing with the example 2. Okay, so this is 0, this is 3, this is 0. Okay, so first thing is that we have to solve for the left child. Okay, this is the order that I'm taking. I'm calling the GFS method using this order: left, right, and mid. Okay, so first I come to this place, then I am checking for this left child of this 3. Okay, so value is null. Then this node doesn't require any children, so I am returning 0 here. The right child value is null for this root, so I am returning 0 here. Okay, this node doesn't need any children. Okay, so how many excess children that I have at this particular node? Simple, value of this node is 3 plus my left excess value is 0, my right excess value is 0 minus 1. Okay, so value is excess children value is 2. Yes, 2 extra children are there in my left. Okay, 2 extra children are there in my this node. Okay, 2 extra children, right? This is the formula that I have used. So from here I am just going to return 2. Okay, so let me write the formula here if you guys are confusing. Okay, so formula is nothing but excess is equal to node.val plus left excess plus right excess plus minus 1. Okay, minus 1 for my current node because this also needs 1 children, right? So I hope that this is clear. Okay, this is the formula that I am using, right? So now this is done. So from here I am returning 2. Okay, so now same way let's check for the right of this. Okay, so same here, it's going to return null, it's going to return null. Then from here I am going to return 0, and here from here I am going to return 0. And number of excess children this so node value 0 plus 0 plus 0 minus 1. Okay, so that simply means minus 1 simply means that this nodes needs 1 extra children. Okay, needs 1 extra children. So here from here I am returning minus 1, and from here I am returning 2. Okay, so now from this I have to calculate the number of excess children. Okay, for this, so number of excess children for this my root, so node dot value is 0 plus left excess. So from left I am going to take 2 children. Okay, from left I am going to take 2 children, left excess plus right excess. So that simply means I am going to give 1 children to my right, and then minus 1. So see what is the value that I am getting? 2 minus 1 minus 1 0, and that is right. That simply means 0 simply means that this is balanced out. Okay, so because I am taking 2 children from my left, 1 children I am giving it to the right, and here just 1 children left, right? So now I have to calculate the number of moves. So number of moves, how I am calculating the number of moves? So simple formula is moves is equal to moves plus absolute value of left access plus absolute value of right access. Okay, so moves is equal to 0, initially 0, plus absolute of left access is 2, plus absolute of right access is -1, absolute is 1, so total output is 3. Okay, so I hope that you guys are clear with this output. Okay, simple explanation, right? How I am calculating this. Okay, I hope that this is clear. Okay, so now let's understand this with one complex example. Okay, but before that, let's write the code. Okay, let's write the code. Otherwise, okay, then I will show the, I will do the code debug with the third example. Okay, the big example. Okay, so first let's write the same code that I have explained here. Okay, what I'm doing. So this is my method, right? So initially, let's create one variable int moves is equal to 0, and then from here call for DFS, and DFS just pass my root, and from after that just return the moves. Okay, this is what we need to return, the total number of moves, right? So now after that just write one method private int DFS. In this DFS method just pass the my root. Okay, so I'm just going to write tree node. Okay, and let's define this. Okay, if my node value is null, if a node is equal to null, and then in that case I'm just simply returning 0 now. That's what I have explained, return 0. Okay, so see here I am returning 0 here. If a node is null, then I am returning 0. And then also I am traversing left and right. First I am checking for left, then right, then again, then mid. Okay, so here left access is equal to DFS node dot left, and right access is equal to DFS node dot right, and then we have to calculate the total access coins at this particular node after balancing left and right subtrees. Okay, total access coins at this node after balancing left and right subtrees. Okay, so how I am calculating that? So int access is equal to formula, same formula that I have explained, node dot value plus left access plus right access minus 1. Okay, minus 1. And then after that how I am calculating the moves? So moves is equal to moves plus my math dot absolute value of left access plus math dot absolute value of right access. This is how I am calculating the number of moves. Okay, so this is nothing but moves needed is the sum of absolute access coins from both subtrees, and then in the end I have to just return the access coins to the parent. So return access. Okay, so now let's run the code and see if there are any code issues. So all the test cases has been accepted, right? All the test cases has been accepted. Nice. For this we are getting output as 2, and for this we are getting output as 3. Now let's submit the code and see the runtime. So see, our solution is accepted, right? And it beats 100% of users with Java. Okay, so now let's debug the code with example number 3. Okay, so let me copy the code here, let me paste it here, let me arrange it. Okay, this is my code and this is my example. Okay, so here initially number of moves, I have set the number of moves to 0, right? Then after that I am going to call this DFS method. Okay, starting from my root, this is my root, and from here after that I have to run the moves. Okay, so now let's we go to the our DFS method. Okay, so initially my node is not equal to null. So first thing that I have already explained, that we are going to check for the left part. Okay, so from here I go to the left, I reach at this particular node. From here I go to this left, I reach at this particular node, and then from here I go to this particular node. Okay, this is null, this is null, right? So from here I am just returning 0. Okay, that simply means that this doesn't need any children. Okay, if node is equal to null, then I am returning 0. From here I check for the right. Okay, now I call this right access method. So from here also node is equal to null, I am returning 0. That's it. So I have now solved both left access and right access. I have solved it, right? Now after that I reach at this line access. So access at this particular node. So access equal to node dot value 0 plus 0 plus 0 minus 1. That simply means minus 1 simply means that I need one extra children here. I need one extra children here. Okay, one extra child here. So from here, okay, access. So I am returning access as well. So from here I am just going to return minus 1 to this node. Minus 1. I am returning minus 1 to this particular node. Okay, minus 1 return access. Then after that I have to check for the right. Okay, so from here I go to this right, and then from this 2 again I need to check for the left. Okay, again left. For this 0 I am again going to check for my left and right. Both are going to give 0 access value because they don't need any children, and this 0 is going to give minus 1 because this 0 needs one extra children, minus 1. Then after that I go to the right of this children, and then again for 2 I go to left, I go to my right, and both are going to return 0. Okay, as I have already explained. And this 2 is going to return 1 because there is one extra child in this node. Okay, so from here I am returning 1, and from here I am returning minus 1. From here I am returning 1. Okay, so number of access children that this node has, so say use same formula, node dot value is 2, and in the left access I am giving one child. Okay, minus 1. So here I am writing minus 1, and in the right access I am taking one extra child. Okay, plus 1. Value is 1 now, that I am returning here 1 minus 1. So what is the total value? Minus 1 plus 1 cancel out. 2 minus 1 is 1. Okay, so that simply means that there is one extra child here. That simply means one extra child, and this one I am returning from here. Okay, this one I am returning here. Okay, and here for this node 2 I am calculating moves as well. So initially my moves are 0. Then after that I have added the absolute of left axis. So absolute of left axis is minus 1. So 1, and absolute of right axis is nothing but 1 only. So total value is 2. And this is right. Why this is right? So see, this is how it looks like, right? 2, 0 in the starting, 2, 0 and 2. Okay. So see here how many moves that I am taking. From 2 I send one children to this one. Then it will become 1, 1, 2. Okay. Then from 1, then this will become 2, this will become 1, this will become 1, because I am sending one children from this node to this node. So total 2 moves. Okay, this is first move and this is second move. Okay, so 2 children, and this is right, 2 moves. Okay, 2 moves now, 2 to 1. Okay, 1, 1, 2, then 1, 1, 2. Okay, sending one children from this to this. Okay, initially I am sending one children from here. Okay, so I hope that this is clear to how why 2 moves are taken. Okay, so from here total 2 moves are done. So this is an arbitrary value of moves. Okay, and then I have returned 1 here now. For this I have to calculate then number of access children that this node has. So node dot value is 0 plus left access, so minus 1, 0 minus 1 minus 1 plus right access 1, 0, so minus 1. So from here I am returning minus 1 to this 3. I am returning minus 1 to this 3 if you calculate the access value. Okay, node dot value 0 minus 1 plus 1, 1 returning right, minus 1. Okay, so from here I am returning minus 1, and this is right, this node will return minus 1 only. Okay, so from here I am giving one extra children, right? From this one I am giving one extra child here, and this extra child is going to this left child. Okay, so again I left out 0 only here, so that is why I need one extra child, minus 1. Okay, same way we have to check for okay, so here this is done. Then I have to calculate the number of moves as well, number of moves. So Number of moves is initially my number of moves is 2 plus left axis minus 1, so absolute value 1, and here I am returning 1. So 1, 2 plus 1 plus 1 is equal to 4. Number of access children I have is 4. Okay, till now. The number of moves, this 4 is nothing but number of moves. 2 initially I have 2, then plus 1, this absolute value and this absolute value. Okay, to total 4. Okay, then again for 3 I need to check for the right of this 3. Okay, so here 0, 0, null, null, both are returning null, null here, both are returning null here, and number of excess children in 0 is nothing but minus 1 because I need one extra. Okay, so from here I am returning minus 1. Okay, so now number of excess children I have in these 3. This is the final step in my route. Okay, so 3 node plus minus 1 for the left axis plus minus 1 for my right axis, and then minus 1 because my this route also needs one child, right? So 0. Okay, we are fine. That means that we have covered all the nodes with one value. Okay, so now calculate the moves. So total number of moves previously was 4 plus absolute of my left axis 1 plus absolute of my right axis 1. So total output is 6. Okay, total output is 6. Now let's check whether we are getting the same output. Okay, so let's create one test case. 300. Okay, so how my tree is looking like? 300, 02, null, null, 0, 2, null, 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 0, 2. Okay, this is how my tree looks like, right? Let me copy this here to see, validate one more time. 3, 0, 0, 0, 2, then 2 null for this 0, 0, null, then 2 nulls for this 0, 0, 0, 2. Okay, now let's run the code and see whether we are getting the same output 6 or not. This is our case 3. So see, we are getting the output as 6. Okay, so I hope that you guys are clear with how we debug the code. Okay, so if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye, and don't forget to like this video, share this video with your friends, and please subscribe to my YouTube channel. Thank you, bye bye, meet you guys in the next video.